Hey guys, here is the review for the last two integrals that you have to learn for dual credit. So this happens when there's some trig integrals with high powers. We somehow have to convert them using trig identities and U substitution. So I'm going to go through two of these. Take notes because this can help you for the dual credits. Hint, hint, same concepts, just different numbers. Okay. So if we have cosine cubed sine to the fourth, we want a u substitution. So we want to try to get a u and du situation. We frequently use the higher power as the u, and so we're going to make sine our u, which means its du is cosine. So somehow we want just cosine here, we don't want cosine cubed. So if we just want cosine, let's go ahead and take out one of the cosines. That will make this cosine squared times cosine. Now we have our du present, and we have u to the fourth power. But we need a u and du. This cosine squared is kind of messing that up. So if we could get cosine in terms of sine, we could replace it with a relationship it has with sine so that we have everything in terms of our u. Well, it goes back to our trig identity. The fact that sine squared plus cosine squared equals 1. So if we want cosine squared, we can solve this so that cosine squared is equal to 1 minus sine squared. Once we have that relationship, we can now replace cosine squared here with what it equals, 1 minus sine of squared. So now this is in terms of, like everything here is in terms of u, and then we have a du present. Well, we're not quite ready to integrate because if we tried right now, we would have u, du, and 1 minus u. And the 1 minus u in the multiplication problem will mess it up. So what we can do is we can take this cosine x sine to the fourth and distribute it in and break up this 1 minus sine squared. When we do that, when we distribute both of these to the 1, it just stays cosine sine to the fourth. And then when we distribute both of these to the sine of x, or sine squared of x, it stays cosine, but then the sine to the fourth multiplied by sine squared makes us sine to the sixth. So that's what we're left with. And then remember when we add or subtract, we can treat these as two separate integrals. So we could throw that sign in there. And now we're ready for our u substitution. We have everything in terms of u and du. We've broken it up into two separate integrals. So now we can throw in the fact that sine is our u. So this turns into u to the fourth. Cosine is our du. So now we have u to the fourth du. We'll do the same with the other integral. Sine is our u, so we have u to the sixth. Cosine is our du, so this turns into u to the sixth du. Now we're ready to do our integration, where we add 1 to the power and divide. So that makes this 1/5 u to the fifth, minus 1/7 u to the seventh, and then there's no bounds, so we'll have our plus c. Our u is sine of x, so we replace that back in with u. So a lot of steps here just to get to our u substitution, but we had to get it in terms of just u and du so that we could integrate. Let me know if you have questions on that one. There is one more of this style, and it deals with a secant and tangent. So it's a super similar process, but just different u and du situation here. There are two relationships. There's, if we made u tangent, du of secant squared could be present. We could break secant to the fifth power into secant cubed, secant squared. So we could have a u and du. Or the other way, if we made u secant and our du secant tangent, we could make that as well because we can use our trig identity here. If we divide it by cosine, we could somehow get a relationship between secant squared and tangent squared, which we will need later. So I'm kind of just setting up, we have options here. But here's my little hint. Frequently the higher power is what we want to make u, but also if tangent and secant are in the same integral, it is actually going to be easier for us to use secant for our u. So if you see this on dual credit, hint hint, make your u secant. If we make that secant, we want a secant tangent present for the du. So if we want a secant tangent present, we're going to take one secant and one tangent out of each of these. So when we do that, our secant to the fifth becomes secant to the fourth. Tan cubed becomes tan squared if we take one out, and then our secant tangent is still in the problem. We just basically factored one out of each term. Now I also want to do this because tangent squared, as we saw on the previous screen, tangent squared is part of a trig identity. We use that idea that if we could convert this into some sort of secant, which is our u, then we could replace tangent squared out of it. And so that's where if we take our sine squared plus cosine squared equals 1 and we divide it by cosine squared, sine divided by cosine gets tangent, cosine over cosine is 1, and 1 over cosine will get secant. So we can rearrange this formula so that our tangent squared is equal to secant squared minus 1. The reason why we want to do that is because now we can replace this tangent squared and get this whole problem in terms of our u and du. We don't want tangent squared in there, we want anything that has to do with secant. So we're going to replace our tangent squared, secant squared minus 1. Like before, we want to break this up. We can't integrate this all together, so we're going to go ahead and distribute the secant to the fourth in here and the secant tangent. So when we do that, it's like we're double distributing. Secant to the fourth is getting distributed to this first term, but so is secant tangent. Secant to the fourth is getting distributed to the minus 1, but so is secant tangent. So when we double distribute those, it becomes secant to the sixth, secant tangent. And then secant to the fourth, secant tangent. If you need to do that in two separate steps, you absolutely can. Distribute one, see what you get, then distribute the secant tangent. But this is what you're going to get, and like before, you can treat this as one integral, or you are able to, I think my S is an integral sign. There should be another one here. When you subtract, you can treat this as its separate integral. And now we go to our u substitution. The fact that our secant is u and secant tangent is du means we have everything in terms of u and du. So secant to the sixth turns into u to the sixth. Secant tangent turns into du. And you can see our other one would subtract u to the fourth du. We now have everything in u substitution form, so we'll add 1 to the power and divide by that new power. And then we will finally substitute our u of secant back in. So similar steps with both. It really comes down to what are you making your u and du. Make sure you have your du present, and then use this trig identity. Which slide is that? Sorry, this one. You can use this trig identity to convert it into a certain relationship to replace one of them. Okay, so come to class with any questions you have. Otherwise, you are ready for the dual credit whenever you are ready to take that. Okay, see you later, guys.